the vector product. So, so far we have learned about the scalar product, right? When you actually dot product or scalar product two vectors, the resultant is a number, which is known as a scalar because it doesn't have direction. Okay, so A dot B will produce a number, which is known as a number or a scalar, right? Next, now we will look at if it's the cross product, right? So if A and B are two vectors and you're actually multiplying two vectors, when two vectors are being multiplied, or we call it cross product or vector product, is denoted as vector A cross product or multiply vector B. So the resultant will be a vector as well. Okay. So the major difference between the vector and the scalar product is simply scalar product will produce a scalar, a number, and vector product will produce a vector. Okay, it has direction, right? So any two non-parallel vectors A and B define a plane. Example, if n is a unit, right? So it will form a diagram such as below, right? The scenario where two non-parallel vectors A and B define a plane. So let n be a unit vector perpendicular to the plane, right? So that A, B, and n form a right-handed system. So in this right-handed system, your A, example A will represent along your fingers, B from the palm, and N will be along the thumb. So for example, you need to picture this yourself, right? And in this case, the angle between A and B need not to be necessarily 90 degrees in order for the cross product to take place. Right? And by definition, the vector product is defined as A cross product B, N or U. In this diagram, is shown as U, which is also same as N. Presents NAB sine theta, right? So in this case, theta is the angle between the positive directions of A and B as well. And either A or B, if it's a zero, right, then N becomes undefined as well. And obviously, cross product will result in as a zero. So based on the cross product or the vector product, there are some properties which are necessary to be highlighted here. So A cross B is a vector with the same direction, all right, as N, based on the previous diagram, or U. Sometimes certain literature uses U. Okay. So A cross product B modulus will similar to be modulus A modulus B sine theta. Okay, and it also represents the area of the parallelogram defined by A and B. And if it's vector A cross product vector A, right, and the angle between these two vectors is obviously zero, so sine 0 is 0, therefore the resultant here is 0. Okay, and it's a similar if two vectors are parallel, and we will also have a vector product of 0. Okay. And same goes as A cannot be a 0, vector B also cannot be a 0, and therefore cross product of A and B, if it's a 0, it proves that A and B are two parallel vectors. Okay, so you can sometimes you need to use this to prove whether two vectors are parallel by simply doing the cross product and finding the magnitude of it. Next, the scalar product is commutative, but the vector product is not commutative. We will see the practical parts in the coming slides where I'm going to show you how do you actually calculate your cross product. So when you do a dot product, the arrangement does not matter, but when you do the cross product, it matters. So vector products are not commutative. As you can see over here, A cross product B, it cannot be negative cross product B multiplied by A. You will not get the right answers here. And next, if it's vector I times j, and then it will result in k, all right? Simply because sin 90 is 1 and ij are unit vectors, okay? if similar to ij, right, it will also result in k. Similarly, if you have a look at this diagram, this is how you actually can remember cross product of I and j. So these 6 results here are simply a product of, you can memorize it using this diagram. So as you can see, there are 6 products here. So you can memorize it using this diagram. This diagram simply says clockwise will give you a positive result. So if I is clockwise, j is positive, yeah, right? And then if it's j times k is also positive I, right? And then if it's k times I is clockwise, is positive j, right? And then if it's you move on, and if it's the opposite direction, which is anti-clockwise, so if k times j, it will be negative I times, if it's anti-clockwise, yeah, so if it's I times k, it will be negative j, right? And also k times j, it will be negative I, and j times I, which is anti-clockwise, it will be negative k. So you can memorize this by using this simple diagram. Just remember that clockwise is actually positive resultant and anti-clockwise is negative. The vector product is distributive over addition. Okay, this simply means that if you have A cross product with B plus C, you can simply cross product each individual A cross product B, and you can add it with A cross product C because it's distributive over the addition. Okay, and also you can also arrange it as vector A, vector B, and you add them up first. Okay, instead of over here is A cross product B plus C. Over here is A plus B, vector B, and then cross product C. It will be same as A cross product C added with B cross product C. So this is a very important distributive over addition for vector product. Yeah. Next, for example, if you need to identify the cross product for these two vectors. So A has a magnitude of 3 and B has a magnitude of 3. And the angle between vector A and vector B is simply 60 degrees. And they are both pointing out from the original point here. Okay. So we're going to take the direction 3 and set 3 as being positive. Okay. So in order to identify A cross product B for these two vectors, you simply multiply the magnitude, which is 3 times set 3, and the angle, which is sine theta, which is 60 degrees. Okay, so you will get your value 9/2. And if you need to identify cross product of B times A, right, it's similar to 3 times set 3 over here, and also sine of 60 degrees, so it's similar. Same magnitude, but the sense is different, as in the arrangement of it is different. Now we're going to look at the component form of the vector product. So for example, if we're given A in the component of A1, A2, A3, and B as B1, B2, B3, so we're required to find the vector product. So it's simply A cross product B, right? So it will be a cross product the two vectors, which is A1, A2, A3, and B1, B2, B3 respectively, multiplied by I, J, and K. So in order to expand these two vectors or cross product these two vectors using the distributive law, which we introduced in the previous slide, it will be as stated here. Okay, and there is an easy way. I'm very sure you don't want to memorize this. There's an easier way to actually multiply the vector product using from component forms, right? So when you simplify this is for proving purpose. When you simplify this, so here you simply multiplying each of it, yeah, each component of it. So basically you will have 9 components, like A1i multiplied by B1i, B2j, and B3k is only 3 different values, and then A2j multiplied by everything on the right, which is B1, B1i, B2j, and B3k, and then followed by A3k multiplied by B1, B2, and B3 ijk respectively. You'll have 9 different components, and remember that diagram I showed you just now. You can identify what is I times I times j, whether it's positive or negative, and what is the resultant. So I'll show you the first line. Yeah, so I times I can simply will be a 0 because the angle between the two, right? So sine of a 0 is a 0, and then when is I times j, right? And I times j is clockwise, right? So it will be a positive k. So you will reduce your value to a1, b2, k. Okay? And then next, a1, b3, I times k is simply anti-clockwise. So I times k will give you negative j, right? Negative j, and a1, b3 follows, right? So you have to solve each of it individually using that tips to remember the clockwise and the anti-clockwise law, right? And then you will arrive to your simplified answer, and it will be simply this. So if you would like to remember how do you actually determine the component form of a vector product, it's simply by using this formula. So provided your A1, A2, B3 is written in such a way, okay? So this is the final formula. We are using distributive law to prove that that is the final formula. Okay. So if in your exams you write a final formula and you do the calculation is sufficient, you don't have to prove using the distributive law. So this is the formula which we have obtained from using the distributive law. And this formula can be quite confusing at times. There's a lot of notations here, 2, 3, and so on. So you might substitute it in a careless way, right? So but anyway, there is an alternative to this. If you do not like this formula, that the alternative is using the shortcut notation. So how are you going to use the shortcut notation? I'll show you over here. So you start off with A cross product B, right? So in order to find I, how to get this formula. So I'll show you how to get this red boxed part. Okay, how to get the red box part. So you have to simply close the row and column that is associated to I. So we will close this row and column. Okay, so what is left here? It's E2, E3, B2, and B3. All right, and you simply add a modulus to it. So this modulus is actually finding the determinant. So when you want to find the determinant, it is simply A2 times B3, right, minus A3 times B2. Okay, so A2 times B3 minus A2 times B3 minus A3 times B2. So that's how you get this, and because it's associated to I, we close the row and the column associated to I, so we multiply with I over here. Okay, so next, I will show you how do you get the second part. You just need to remember that it's always a minus. Right? When you want to determine the component for J, is always a minus here. So please pay attention, it's a minus. Now I'll show you how I got this A1B3 minus A3B1. So what you can do here is simply, I'll show you. Okay. So this green box here is identified by, so this is associated to J. Remember, it's always a minus, yeah. Okay, it's a J. So we close the row and column associated to J. Okay, So it will become, so we will write out what is left in the modulus form. So what is left is E1, B1, E3, and B3. And B3, right? In modulus form. Okay, so how are we going to obtain the one that is green boxed over here is simply by applying the determinant formula, which is A1 times B3, sorry, A1 times B3 and minus AD minus BC, right? So A1 times B3 minus A1 times B3 minus A3 times B1. Okay, and this has to be minus. Okay, this is associated to J. Next, it's the one that is associated to K. So what we do over here is we simply identify the row and column which is associated to K, which is this. Associated to K, which is this, and we need to identify what is left for the determinant, which is A1, B1, A2, and B2. Okay, so in order to solve this, we have actually got the boxed purple formula. How do we get this? Is by simply using the determinant, which is E1 times B2, take away A2 times B1. A1 B2 minus A2 B1 and multiplied by K, right? So you can use this shortcut notation to actually get the vector product calculation in from component forms. Now we're going to calculate area of a triangle whose vertices are given as ABC. The diagram is shown here and theta has a value. So all we need to do is we need to recap the basic formula to determine area of triangle, which is simply half AB sine C, and the A and B has to be magnitude, right? So in this case, in order to identify vector AB, AC, magnitude of vector AB and AC sine theta, it is equivalent to the cross product of vector AB and AC by the definition of the cross product formula. Okay. So in this case, because we have the vertices, we can come up with the vectors. So vector AB is simply B minus A by the basic definition. So 5 minus 2 is 3, sorry, and negative 1 minus negative 1 will be a 0, and 2 minus 3 respectively is minus 1. So that's how you got AB. And vector AC will be simply C minus A. So 2 minus 2 is a 0. And 3 minus negative 1 is 4. And 4 take away 3 is a 1. So that's how we actually arrive to the components of AB and vector AC. Next, we need to, because it's a cross product, so we need to conduct the shortcut that we learned just now using the IGK modulus form. Right, so this is vector AB. So we write respectively 3, 0, negative 1, the respective I, J, and K components, and followed by vector AC. Right, and we perform the shortcut method that I have showed you just now. We will get the individual component of I, J, and K. Okay, and this will result in a vector. And we need to find modulus of the vector. So the modulus of a vector can be identified simply by squaring each component x, y, and z here, which is 4, negative 3, 4 square, negative 3 square, and 12 square, and add them up and you insert them, and you can actually find the area of this triangle ABC. Next example, if you're required to calculate the shortest distance between a point P to the straight line passing through point A and B. So for example, if this is point AB and this will represent vector AB, the length will be the magnitude, and there's point P over here, and you're required to calculate the shortest distance from point P to the straight line AB. So obviously the shortest distance mathematically has to always be perpendicular to the opposite side. Okay, so in this case, P and P prime, all right, so we are taking P prime. The point is directly perpendicular to the opposite direction, so that's this angle P prime A is actually 90 degrees. So we can come up with this conclusion, right? So in this case, since AP is multiplied by is sine theta, all right, so in this case we can further expand this formula to AB AP modulus AB AP sine theta over AB, right? So we can further write it in this form, because modulus A modulus B sine theta is equivalent to cross product of modulus AB. This is the distributive law just now that we learned on vector product. So in this case, we need to identify vector AB and vector AP. So vector AB is simply B minus A, and vector AP is simply P minus A. So you have the respective AB and points P. And then you determine the cross product, which will represent AB cross product AP, right? Using the IGK and the shortcut method just now. You will arrive to IGK being in this form. Okay, and don't forget to copy down your modulus, because the modulus will actually ensure that you can actually get a magnitude. So you square each component, -4 squared, -5 squared, and -1 squared. And then next, you also need to find our magnitude of AB, so it will simply be 3 lah. It will be 14 units.